Alright, welcome back everyone. Today we're going to be taking a look at Gaussian Splatting in TouchDesigner, which is something I'm super excited about because it's very new and it is, I think, potentially very big and game-changing. So first off, I want to say thank you to Tim Gerritsen and YFX Lab for creating this implementation and giving us the ability to look at Gaussian Splatting in TouchDesigner. It's been a long time coming, and I could never have done it myself, so I'm very glad that somebody more intelligent took the time and was gracious enough to share it with the entire community. So for that, thank you. And now, let's jump in. So a couple weeks ago, did a tutorial about using Luma AI captures in TouchDesigner. And this is going to be building off of that because I'm using Gaussian Splat files that were created in Luma. So I'm just going to be adding two. We've got the rest of the tutorial here. I'm not going to go over any of that, but feel free to go back and look at the prior tutorial or grab the project file and assets from my Patreon. Oops. So to get this component and get started, can just go to this link, which I've already got for us here. And this is where you can get the asset download, and that's just the tox itself. I guess maybe, there you go, the tox itself. You can just click on that and download it. And then he goes through just a little bit of how to use. So feel free to give it a read, and I'm just gonna look into it by first deleting this component and then going to my downloads and grab this Gaussian Splatting and just drop it in here. To note, you're going to need TouchDesigner 2023 to make this work because that's what this component was created in, and there is no longer backward compatibility. So drag and drop that in. At first we don't see anything, and that is because we need to just update this Gaussian Splat file to some other file, or you can go and download this sample file from poly.cam. If you've already downloaded anything from there, it'll make you pay for it or sign up for an account or something weird, so you can also just grab your own from Luma, which have been working phenomenal for me, and that's the purpose of this tutorial. So there are a couple of things that I want to do just to kind of quality of life improve a little bit before I get going. The first is we can see that our layout width and height is our render resolution there. So I'm just going to open up my project parameters and just drag and drop my updated resolution here so that we can render in 4K, keep things looking a little bit sharper. Now, you may not all be able to do 4K. I have a decent GPU here. This is not the lightest algorithm in the world. It's running about 4 milliseconds for me to render this flat using a Gaussian Splat that's not like a terribly crazy file size. And yeah, so that's taking about 4 milliseconds to render without camera movement. Camera movement will substantially increase that time. To look around, you can just use the camera viewport that's provided. You can change your camera if you like, but I found it not super necessary. And the camera viewport that comes provides a pretty good way of just kind of exploring your splat and starting to get a feel for what's going on. Now, if I turn on auto rotate and just auto rotate this a bit, we can see that the GPU cook time has actually gone down a little bit here, which maybe means there's less primitives in our current view. But we will have updated calculations based on the primitives that are in the view of the camera at a given time. So that means that our rendering computation costs can go up and down a little bit depending on other settings. Zooming the whole way out, we can start to get a look at maybe what these scenes look like when they're not rendered so nicely. And it looks, you know, a little bit chaotic around the edges, but as we zoom in, we can start to recover a lot of that internal structure. And this kind of, let's say, dichotomy between a pretty sharp foreground and then some very diffused or scattered backgrounds, I think is pretty interesting, and one of the aesthetics that I really like about this new geometry type. So before we get into things and kind of talk about maybe some ways to make these Gaussian splats interesting in your own inside of TouchDesigner, let's talk about what Gaussian splats actually are. So a Gaussian splat is just a name for a different type of rendering primitive, actually. And so your normal rendering primitive that I'm sure everyone's pretty familiar with are triangles, quads, whatever, lines, points. These small pieces of geometry that are then textured and rendered to screen to create these polygons. Gaussian splatting is kind of a different way of thinking about rendering a three-dimensional scene. And instead of each point or primitive being a quad or a point, I guess, with a specific color and vertices having specific colors assigned to them, Gaussian splats actually represent that data as a distribution. And so that's the Gaussian term of this. So you can think about the Gaussian splat as being a collection of a bunch of points, each of which has a distribution for color and opacity and also scale distortion. And so that means we end up having a bunch of different points, and each of them is rendered kind of like a little oval with transparency fall off, so like the edges are feathered. And the scale and size and orientation of the oval is a function of the distortion distribution, and the coloring and opacity is a function of the coloring and opacity distributions, all of which are then overlaid on top of each other and splatted against a two-dimensional plane, or projected, if you will, splatted on this two-dimensional plane, and all added together. The splat is a function of the camera direction. So we're really saying from where the camera is in my virtual space, project through all of the different Gaussians that are able to be seen by the camera, so essentially like a path tracing, and accumulate through all of the Gaussians that a given ray is going to intersect, sample what their color and opacity is at that ray's location, and aggregate all of those Gaussians together, e.g. splatting them onto a two-dimensional plane, and adding up their color and opacity to render what we're seeing in front of us. That all might seem a little bit heady, but actually, there are a couple parameters here that we can use to understand a little bit more intuitively without actually doing any more work. So the first thing I'm going to do is just turn up this alpha threshold. This alpha threshold, if you go inside, we've got a custom GLSL material that's doing pretty much all of the heavy lifting. But the alpha threshold we have somewhere, actually I'm not sure where that parameter is being used, I forget, but it doesn't matter because we can increase this alpha threshold and basically just harden the lines around our Gaussian splats. This render is not quite wired up the way that I thought it was. So I'll just drag and drop these width and height. So now we have a 4K render, or the maximum resolution that you're able to do it in. That's also probably why my performance was much better than I expected. So yes, this is now rendering 6.5 milliseconds to render this in 4K. And if I just move, let's see what happens if our camera is animating. And then yes, we can see that now it's taking like 10, 11, 12 milliseconds to calculate this scene dynamically. And that is much more expected, especially at this resolution. So I'm going to turn off the auto rotate, and well, I'll just leave it here for now. This is showing us what is going on and what these splats actually look like. This is because we have the alpha threshold much higher, which means that the soft feathering, which you can start to see if you blend that alpha threshold down, is gone completely. And we only see these hard edge splats. Now, as we decrease the alpha threshold and start to bring that blend back, you can really see what's going on. For example, right here, this pretty large splat is right over the top and just adds that kind of white, but really is almost invisible, and it actually contributes more to highlighting in some areas than actually kind of like a white form. Similarly, we can see like this purple over in the corner. As we increase it, the purple still does accumulate, but it looks much more well covered. And so it starts to give you a little bit of intuition. Each of these ovals, or ellipses, is really a Gaussian splat that has a color and opacity distribution being used to render. We'll turn that alpha threshold down pretty far and reduce the splat size, and we can again kind of see what happens. This looks a lot more like a point cloud, where each of the splats retains its color but becomes much smaller. And in this way, you can start to see exactly how much of a point cloud we really are talking about here. Which makes sense because the actual point file in, especially when you're just looking at the X, Y, and Z locations of a Gaussian splat, look like a point cloud. And indeed, we actually used the Gaussian Splat point cloud files specifically in our last visualization tutorial when we were just looking at the points themselves before this Gaussian splatting technique was available. So we basically just have a point cloud, and at every one of those points, this distribution is being drawn. Now, the distribution itself is non-trivial to calculate. There's a lot of machine learning that goes into it, and we get a little sense of that when we look at the color computation, which essentially is pulling out a bunch of different layers from our point file, or from the Gaussian splat, each of these being specific coefficients that are then used in the color computation, which we can see the output of. And then finally, the positions are sorted based on camera direction. So this sorting is pretty intense. There's a lot going on. Shout out David Braun, as always. But really, the high level is that we're calculating the position of each point to the camera based on the camera direction of view, and then sorting based on that direction of view so that the splats nearest to the camera contribute the most to the final result, and the ones further away obviously contribute less to the final result, visually speaking. So we can look at another file just to see what a difference looks like. And so this is a very different file and a little bit more of an abstract capture to begin with. But it's kind of cool because you can see that there are a wide variety of different types of visual effects that can be reached with this technique. And I think there's a lot of creativity to be done in the data capture itself. Certainly something that I want to explore. This specifically is a capture of sand on my kitchen counter. So I'm going to go back to the other one because it's a little bit easier to see what's going on, and therefore I think easier to follow along. Just leave that right about there, maybe. And so now maybe, and I hope there's a bit of an understanding on what Gaussian splats are intuitively and why the rendering looks so good, frankly. What this means is there's quite a bit of extension, and I would like to first just select the background top one level up so that I can look at it here. And I'll display it, and this way we can just see what's happening while we're making a couple changes. Now, I'm not going to go through an exhaustive kind of this is everything possible here because I don't know everything possible. But there are a couple, I think, low-hanging fruits that are pretty fun to experiment with. The first is going to be simply adding a little bit of noise to the points. So here, I'm just going to drop down a noise, turn off monochrome, make sure that it's a 32-bit float, and then I will drop my offset to 0 and drop my amplitude to 0. So now there's no noise happening, there's no location distortion. And as we turn up that amplitude, you can see that our locations start to distort. But interestingly, or perhaps not interestingly, but aesthetically interestingly, because the colors are all being looked up after this point transform, the colors are all kind of associated continuously, meaning we don't lose a ton of color information. You can see it looks a little bit different if we do not use the same transform on both. Or I guess maybe better yet, if I just use the point transform on scale but not on color, and now you can see very substantial differences, obviously. So you want to make sure that you're changing that point location before you're passing it into the calculate color talks to maintain some of that relational information. So this is a really easy one. You can obviously animate it. You can obviously do a bunch of other stuff, but that's pretty fun. And just as simple as adding a little bit of noise there. You can also add a little bit of noise and then use a speed chop and just translate this noise based on the speed. And then we have already a pretty nice, interesting, breathing little plant. We'll bypass that noise for a second, and I will add another one, and that will be here in our scale. So for scale, actually going to turn my offset the whole way down again, but keep monochrome on. And now we can see that as your scale changes, the, let's call it fine edges, start to erode. And that's because there's a lot more overlap than was originally expected when the Gaussian Splat was trained. If we turn up the alpha threshold quite a bit and then come in here and go back to our scale noise, we can see what's happening a lot more clearly. And that is that these Gaussians are exactly that, just increasing in size and overlapping much more. And so the final render pass that goes through and accumulates the results of all of these Gaussians is incorporating information from a lot more points than original. And that is what gives this interesting look. Now, I like it a lot because I think it looks kind of like breathing, especially if you animate this. It's kind of just like into focus, out of focus, into focus, out of focus. And that's something I like. So I'm going to use this LFO, and I'm going to make it not a very big LFO, just 0 to 0.05, and then I will use Alt-N and just drag and drop this onto my noise amplitude. And so now, very, very, almost imperceptibly, maybe I have to make it a little bit bigger. Let's say 0.25. Okay, so now it goes from 0 to 0.5, and we can see that this kind of breathing dynamic is now here. I'll turn down the frequency a little bit, and now there's a pretty nice animation. That's good. Very subtle. We can turn this noise back on and potentially use another LFO for, let's say, the noise amplitude. This noise amplitude. And in this case, maybe we don't want it quite so big, although that is definitely interesting looking. Maybe in this case, I will put it back to 0.05. And so now there is multiple dynamics at the same time going on to permute this Gaussian splat, and we can start to see, I think, some of the areas for extension. Especially if I change this phase a little bit, and I'll change the frequency of this as well so that there's not quite as much overlap between the noise and the scale. And there we have it. It's not anything super crazy, but the intent of this tutorial is more to illustrate the new geometry primitives and then start to build some intuition for some techniques that might be possible with them that weren't possible with other types of geometry primitives before. So this is, I would say, one of the areas that I'm most excited for, and there's a ton to be done. There are, I think, quite a bit of other extensions, but I'm going to leave this tutorial around here for now because it's been about 20 minutes and I want to keep it there. So I will say thank you to Tim Gerritsen one more time for this implementation. I hope that this has been informative and opens up a little bit just some creative juices flowing, starting to use some Gaussian splats in interesting ways. Thank you all for watching. Thank you all for the Patreon support. This file is, of course, available on Patreon. Thank you again very much for that support. And until next time, I wish you all the best and happy creating.